Hi there, myself Madhav Jha. I welcome you to CodeChef and let's have a look at this question.
The problem is less than max. The problem difficulty is easy and there are no prerequisites. Let's have a read at the problem. An array B of size m is called good if for all indexes I that are greater than equal to 1 but less than equal to m, either follow the following conditions. First, that the element is 1 or there exists another index j such that jth element is equal to the ith element minus y. Now, we are given an array A of size n and we need to find the size of the largest good subsequence B of A. B is said to be subsequence of A if it can be formed by deleting several elements from the A without changing the order of the remaining elements. For the input format, we have t test cases, and for each test case we have two lines. The first line contains the integer n, and the second line contains n-spaced integers, those are a1, a2 till an. As for the output, on a single line we have to output the largest good subsequence A's length. For constraints, number of test cases will go from 1 to 100, length of the array will go from 1 to 100 as well, and the value of elements will go from 1 to n. Let's see some sample inputs. So for the first sample input, the array length given to us is 4 and the array elements are 1, 2, 3 and 4. The very first element that we have is 1. As we have seen, one of the conditions that an element should follow is that it can either be 1, here it satisfies that, therefore we can include this in our subsequence. Next up we have the number 2. Now the first condition is that the element itself is 1. The second condition is that we should have another element that exists which is less than 1 to the current number that we are checking. So in this case we are checking for 2, so 2 minus 1 is 1 and we have an element 1 that we have already chosen in our subsequence. Therefore, we can include 2 in our subsequence as well. Similarly, we can include 3 and we can also include 4. Therefore, the answer here is 4. Let's see the second sample input. Here the length of the array is 5 and the elements are 1, 3, 1, 2 and 3. Again, we can obviously include 1 here because that satisfies the first condition. Next up we can choose 2 because we have the number that is just before 2. We have 1. Now that we have chosen 2, we can choose 3 and with this we have the 4 numbers. Therefore, the answer here is 4. Similarly, for the final sample, we can see that all the elements are 2. We cannot choose any one of them because if we choose them, we do not have a number that is just less than them. In short, we do not have 1 here. Therefore, the answer here is 0. Let's see how we can approach the solution. So as we have seen, the first thing that is clear to us is that we must have 1 in our subsequence. Because if we took any other number, let's say x, then the condition demands that we also have x minus 1. Only number 1 is exempt from this condition. So let's say we initialize a maximum that we are currently on. This is initially 0. What we are looking for is something just greater than this. That is, we are looking for 1. Now once we have 1, what is the next number that we can choose? The next number that we can choose is true. Because we cannot choose 3 or anything other than that. We can only choose that is just greater than this. Now that we have chosen 2, what is the next number that we can pick? That is 3. Simply we can choose 4, 5 and so on. So we can go only in this increment. Let's take the final example that we took. Here we chose 1 first because 1 we can always take. Next up we cannot take 3 because we do not have 2 into our subsequence. Again we come to 1, we can still choose 1. Then we come to 2. We can choose 2 because the current maximum that we have is 1. Therefore, 2 was selected. Next up, now we can select 3. Why? Because 2 we have already selected. And with this, we found the maximum length of the subsequence that is good. So following this, we can initialize our max to 0 and then go over the numbers from the starting index. If the number is less than equal to max plus 1, that we can include it in our subsequence, otherwise we will reject it. And with this, At the end, we'll find the length of the subsequence, that is of the maximum length, and is a good subsequence. And with this, we'll get our solution. Let's see how we can implement the solution in C++. So for each test case, we call the function solve. In solve, we take the input of n and we take the input of our input array. Once we have this, we initialize our result as 0, then our maximum as 0 as well. Now what we do is we go over each number, and if our number is less than equal to our maximum plus 1, then we will include that number into our subsequence. Consequently, we'll also check and update our maximum value. We keep on doing this for all the numbers and reject any that does not fit this criteria. At the end, we'll have the length of the maximum subsequence that gives us the good array. And as you can see, I got AC in C++ implementation. Let's see how we can implement this in Python. Again, for each test case, we call the function solve, take the input of n and our array. We initialize our result and maximum both as 0. Then we go over each number and check if that number is less than equal to maximum plus 1. If it is, we include that number into our subsequence and update our maximum. At the end, we have the length of the subsequence that is of maximum size and is also good. As you can see, I have AC in Python implementation as well. So I hope you understood the problem, the approach, and how we can implement the solution in both C++ and Python. Have a very good day, and I'll see you in the next video.